This is the investigation task for Chapter 21. It's about life after high school. And what I'm going to do in this video is just give you some hints on how to do the problem. The idea of this task is to apply the information that we've been learning, the skills, and to actually either type up or write up a very neatly written report that uses both the language and writing style, technical writing styles that we've been reviewing, as well as to practice using the notation. So no shortcuts on this assignment. Okay, so the first problem. What we've been given a little contextual information that I don't think is completely necessary, but I think it helps kind of justify why we want to do this study. So something happened a few years ago. We call it 9/11, and there's some thinking that maybe that changed the attitudes of high school students. So we want to compare high school students' thoughts on what they might do after high school to maybe previous years. Okay, so the first question is what sample size should we use? So they tell us they want a margin of error of 0.04, so 4%, decimal number is this. They also tell us they want a 90% confidence interval. So that implies if we do a 90%, okay, then that means we've got 5% here, 5% here. So this would be 1.645. That would be our Z star, our critical value, 1.645. Okay, and then I've already given you a hint, and it says it right here that the sample proportion is 0.63. So that's all we have to go off of. So we would want to start with a margin of error is equal to Z star times the square root of, in this case, P hat Q hat over N. Okay, so we have a number for the margin of error, we have a number for Z star, the critical value, and we have estimates. So we have P hat, we can find Q hat, and then just solve for N. So do some algebra, solve for N, and then be sure to round up and write a sentence. Tell me to have a margin of error of 4% with 90% confidence. In this case, we would need to sample. Okay, be clear as to what you're recommending. Okay, question 2. Here they're asking for a confidence interval. They want a confidence interval for the percentage of seniors planning to go to college. Well, here's the number that's planning to go to college. So you can come up with a total. Okay, and then so we have our P hat. Okay, P hat would just be P hat's just going to be 289 divided by the total that they sampled. Okay, so so what else do we know about a confidence interval? Well, a confidence interval is an estimate plus or minus a margin of error. And as we just did before, okay, so we know our estimate's going to be P hat plus or minus our for 90%, here it is, 1.645 is our Z star, and then P hat Q hat over N. So don't use 0.63, use whatever this is. That goes in here. You know the sample size, you know Q hat, so you can do that. So you're going to get a confidence interval, you're going to get a range, and then interpret the interval. We're 90% confident that, and write it out. Write out what you are supposed to say. Okay, now we want to do a hypotheses test. Okay, so in 1990, well before 9/11, the proportion of high school students that were going to enlist in the military was 4.5. So here's the null hypothesis. So you need to write that out. Write out what it means. It says it right here. And then say P equals 0.045. That's our hypothesized value. And we want to know if that's changed. Okay, so you would write it out that it's not equal to this value. Okay, so that probably implies a two-tail. It's going to be 0.45, so it's going to be a two-tail. Don't know where, but you would want to draw this picture as part of your solution. Okay, and make sure it's a two-tail, so double the p-value. So when you say the p-value equals whatever, the probability of p hat greater than some number or less than some number, multiply it by 2. Okay, so what else have I done here? I've said, okay, we can see that those going to the military, it's 26 out of this total. So I've already done the p hat for you. So remember, the null hypothesis implies the model, so the center should be 0.045. So your job is to find the standard deviation of p hat. So that shouldn't be too hard to find. It's a formula. Look it up. Compute it. Okay, so you got to fill in the gaps. All right. So, the other thing is make sure you check the conditions. So, right, we have the null hypotheses, then we have the conditions. Okay, once the conditions are met, you can use a transition statement. A transition statement to say that you're going to use the normal model to model the sampling distribution of p hat. And then you calculate your standard deviation, so you do the computations. And then and part of that's computing the p-value, and then write a conclusion. And then use the p-value. So if the p-value is really small, that's a contradiction. It shouldn't be if the null hypothesis is true, the p-value should not be way out here. Okay, the p-value should be in here close to what we said it was. If it's way out here, then we reject the null hypothesis. Okay, so on question 4, all they're doing is changing p hat and asking you to repeat what you did in problem 3. So you can skip the conditions. In fact, you can even refer back to just say you're going to use the same hypotheses. So we're just trying to figure out, well, what would it, if we had a bigger p hat, does that change things? So you can just write a sentence that says, I'm going to use the same hypotheses and the conditions still apply. Okay, because the null hypothesis hasn't changed. Although you may have to check the large enough sample condition. Maybe that's the one you have to check. But then do the computations. So your model should be the same, but your sample is different. So compare this. So you're going to get a new z, and you're going to get a new p-value. All right, and then draw your conclusion. Should be pretty straightforward. Okay, now the final question, check the definitions of what a type 1 error is and write it in context. So we have this null hypothesis that p is equal to 0.045. So 4.5% of high school students will join the military. So that, and the alternative is it's not. So I always say that for type 1, assume, say, HO is true. So now, what kind of error? What is the error? Well, if HO is true, the error would be we reject. So what does that mean in this context? Okay, if we reject HO, what does that mean? Okay, and then a type 2 is it. Now that we've assumed that HO is true, now say HO is false. So what kind of error? Now what is the error? Well, we would retain. We fail to reject HO. Okay, so what does that mean in context? So just write that out. Okay, so there's your hints. Again, do a good job on this project. This shows me that maybe under test conditions, maybe that's tough to work under pressure, but here, take your time, do a good job, and show me that you know how to apply statistical theory. Okay, good luck.